Yeah, the broadcast is live. So, ladies and gentlemen, estimated guests, and fellow learners, it is with great pleasure that I, Christina Borua, stand
So,
before
ladies
you.
and gentlemen, estimated guests and fellow learners, it is with
Let me start over. Sorry. Ladies and gentlemen, estimated guests, and fellow learners, it is with great pleasure that I, Christina Borwa, stand before you today as the host of this remarkable event this evening. On behalf of AWS Cloud Club at Lovely Professional University, I extend a warm welcome to all of you joining us live from all around the world. Let's get ready to be inspired as we deep dive into the fascinating world of Amazon Elastic MapReduce. In our continuous efforts to ignite the passion for learning and innovation, we are thrilled to present to you the virtual event Introduction to Amazon Elastic MapReduce. This event is designed to provide you with a comprehensive understanding of Amazon EMR and its capabilities. Our keynote speaker for the event is Mr. Saurabh Bhattacharya, a distinguished expert in the field, will guide us through this exciting journey. During the event, Mr. Saurabh will unravel the intricacies of Amazon Elastic MapReduce and share invaluable insights on how it enables big data processing and analysis at scale. With hands on demonstration, you will witness the power and the versatility of Amazon EMR firsthand. This is a golden opportunity for you to enhance your knowledge and skills in cloud computing, harnessing the potential of Amazon EMR. So, ladies and gentlemen, let's welcome our keynote speaker of the event, Mr. Saurabh Bhattacharya. Over to you, sir.
Hey, thank you, Christina. Just want a quick confirmation if am I audible and my slide is visible?
Yes, you're audible as well as the slides are visible.
All right, thank you. Good morning, everyone, and thank you for connecting today via this YouTube live stream for Amazon EMR. My name is Saurabh Bhattacharya, and this is my 19th year in the IT industry. During my entire tenure, I have wore several hats. Currently, I'm working with AWS Dubai as a senior technical instructor, and I deliver official AWS courses, especially the advanced and specialty courses like advanced architecting, the data analytics, DevOps, migrations, a lot of these courses. I have about few of the AWS certifications and certifications from few other vendors as well. And today I will try to give you a glimpse about EMR, and let's hope if you have some background about data analytics, then hopefully the session will take you a couple of notches above. All right. So let's get started. Starting off with modern data architecture. See, in this world of big data, what we need to understand is a lot of people have different requirements, right? Every company, they have different requirements. Some people, they require a batch analytics. Some people require ad hoc analysis or ad hoc querying capabilities. If I need to process a loan today, maybe I need to know quickly whether someone is eligible or not, right? And I cannot wait like for few hours to get to know that. I need to know right away. But on the other hand, if I have, let's say, 10 years worth of data and I want to figure out like what is the trend in the past 10 years, depending upon the data, how the matrices are moving, is it trending upwards, downwards? Maybe that is something which requires, a batch scale processing kind of a thing. Sometimes I require an in-memory processing, right? What we need to understand is we are living in a world where the data is growing exponentially. So if you focus your efforts into just one area, that might not cut it. So what we need to understand is we need to understand this modern data architecture. All right. And as you can see at the center of this modern data architecture is your data lake. So the data lake is something which is powered by our simple storage service, which is S3, which you can see at the center. And what is a data lake? Data lake is basically a storage where you can store all kinds of data, whether it is structured data, like coming from your relational databases, from your tables, whether it is semi-structured data like your JSON documents, your YAML files, your NoSQL data, or even if it is unstructured data like your text and images and videos and whatnot, right? So data lake is that centralized storage where you can store all kinds of data. And a data lake supports schema on read, which means while you write your data, you don't have to worry about the schema, right? And the next thing is, if I can have a data lake and I can store all kinds of data at one centralized location, then how different services will consume that data. So at the perimeter, you see different types of data stores. For example, for the relational databases, you can see here Aurora is there. Basically, we have RDS, which is a relational database service. For NoSQL, we have about 12 offerings, but DynamoDB is the key value NoSQL database. Then for machine learning, we have SageMaker. For data warehousing, we have Redshift. For log analytics and all, we have OpenSearch service. And then similarly, for data processing, we have EMR. Now, the question is, all these different perimeter services which you see, they all require data in a specific format, right? And I told you when you're storing the data in the data lake, you don't have to worry about the schema. So now the question is, who will do the magic? Who will ensure that the ETL part of the big data is, kind of performed? And ETL stands for extract, load, and transform, or extract, transform, and load, depending upon is it ELT or ETL. And that's where our ETL service, which is Glue, comes into picture, right? If you want to directly run queries, then we have Athena, which is another serverless querying tool, which can directly run queries on S3. And this is what the large enterprise companies are building their modern data architectures around. So this is the architecture which you will see quite often in large companies. Even some of the companies which are starting up nowadays, they are trying to adopt and follow this modern data architecture. Now, once we have understood this, let's try to understand and focus about EMR, because that is the agenda for today's session, right? So EMR, the first thing is, this is basically a platform. All right, it's a platform where you have about 22 open source projects which are tested and integrated into a single solution which is designed to work together. All right. So each project, these open source project in EMR, they are updated like within 30 days of their latest releases, so that as a community you don't have to worry about the testing, the verification, the certification part of it, and maintaining the new components part of it. So AWS ensures that within the release of the latest version for any of these 22 open source projects which are part of this solution EMR, they gets updated within the first 30 days itself of their release, right? The second thing is, the lower cost. EMR pricing is pretty simple and pretty predictable. All right, so you pay per instance rate for every second used. All right, and you can launch a 10 node EMR cluster with applications such as Apache Spark and Apache Hive for as little as like 15 cents per hour. All right, and EMR also natively supports EC2 Spot instances. If you're aware, you can get like up to 90% of discounts for the Spot instances. You can save a lot of money over there as well. So think about a small cluster of like, let's say 10 nodes. All right, for the entire year, if you run that cluster, it might cost you somewhere around like $1,000, right? So which is like maybe 1/30th of the cost of running a similar solution on an on-premises physical data center environment, right? The second thing is, in EMR, you can leverage the S3 storage. So That is something which on which we build our data lakes. All right, so that is great thing. And EMR launches clusters in minutes, literally minutes, like after installing and configuring and fine tuning all the software components which you have, you have decided that you want to be make it part of that EMR cluster. So that is a great thing why a lot of companies they use EMR. Now let's go a little bit, dive deep into the architecture of EMR, how you can, what are the different components and how you can create one. And probably towards the end of the session, if time permits, I will take you through a demonstration where I'll show you all these components which I'm taking you through my presentation. So when you pay attention towards the cluster architecture, an EMR cluster will have three components, okay? Namely a leader node group, a core instance group, and a task instance group. Now, what are these things? So leader nodes, they basically include, the leader service like HDFS name node and Yarn resource manager, all right? And you can launch an EMR cluster with three, leader nodes for high availability, and EMR will automatically fail over to a standby master node in case the primary master node fails, or critical processes like the resource manager or the name node, let's say they crash, or there is any issue with that, right? So in the event of a failover, right, EMR automatically will replace the failed leader node with a new leader node with the same configuration and the same bootstrap action, so that you don't have to do anything over there, right? So HA is inbuilt for you. Now, when we talk about the core nodes, right, so they include the Yarn node manager, which is basically the compute, and they also have the HDFS data node, which is your HDFS file system, right, the Hadoop distributed file system. And core nodes can be added or removed just basis of the resizing. So again, core nodes you can add it depending upon how much data you want to store while you process it. So you can see the HDFS is only there in the core nodes, right? But you have the task nodes as well, which is contributing towards purely from the compute capacity. I mean, there is no HDFS over there. All right, but yeah, they do have local SSD hard drives, because when they are processing something, they want to store that chunk of data so that they can process it. So they have local SSDs, but it's not like the HDFS, which you will find it in the core instance nodes. Now, the beautiful thing about this architecture is that think about an on-prem environment, or think about architecture where your compute and storage are tightly coupled. What do you mean by that? So when compute and storage are tightly coupled, which means if you need to add the storage, the compute needs to be added accordingly, right? Which is not the case here, because what you can do is you can see the task instance node is purely doing the compute part. Now, task instance group is an optional component. I mean, you need not to have it. You can simply go ahead with the leader node and the core instance group, and you'll be good. But the beautiful thing is here, on demand, if let's say your steps increases and the jobs increases, right, you can on demand add these and scale these instances as per your capability, right? So that is a great thing which this architecture provides you. Now, why EMR? Number one, it provides you a lot of compute flexibility, because we have 450 plus EC2 instance types which are there in terms of EC2 instances, and many of them they are compatible for the EMR cluster launch. And you can see you have families like general purpose and compute intensive and memory intensive and storage intensive families for depending on different use cases which you have. For example, for batch processing, usually you'll go with a general purpose instance type, maybe the M5 or M6, families. For the machine learning, people go for compute intensive category. For interactive analysis and for large HDFS, maybe you'll choose between the memory and the storage intensive families accordingly, right? So this gives you a lot of flexibility, number one. Number two, as I told you, that the storage is something which is separate, right? It is decoupled. Now, if you want to use HDFS in the core instance group, you can use HDFS. But what if you have like a lot of data? Because we are talking about big data, right? And the way every companies are collecting the data nowadays, it's like humongous, right? People talk about like petabytes and exabytes, we used to talk about MBs and GBs few years back. And what happens is sometimes people want to save a lot of cost as well, and they want the durability of that data as well. So we do have an integration of S3 with EMR, and we can use S3 as our data lake, as I told you earlier. And we offer one more file system, which is EMRFS. So with this integration, you get an option in terms of S3, which is like more scalable and highly available and highly durable storage solution. So EMR can use S3 for persistent data usage throughout, the life cycle. So with the data now stored in separate data store, you can efficiently utilize the EMR by launching permanent clusters or even transient clusters, by the way. So what is the difference? See, permanent cluster is like a long running cluster. So you switch it on, and then you say that, okay, when my job will be over, maybe more jobs will come in between. So it will keep on running until I go ahead and terminate it. We call it as a long running cluster or persistent cluster, right? But think about a scenario where I need to do batch processing, but I don't want to run it like all the time, because the time when my cluster is running, I'm paying money. Now, for that purpose, we can launch transient clusters as well. And transient clusters, they automatically, they get deleted once the job is done, right? So now think about a use case where your data is in S3 and your transient clusters are spinning up on demand, depending upon whenever you need them. They will take the data from S3, they'll process it, share the results, and they will get, decommissioned. And that way you're automatically, saving money and paying as you go. Now, again, there is a whole integration with the entire ecosystem of AWS services with the EMR. So that is one more, premises why a lot of people who are running, the AWS services and applications, they basically go ahead and leverage EMR because of the tight coupledness, with the integrations with all the services which are there. So you have a lot of connectors in EMR for connecting to any type of use case which you have, whether it is from the security perspective with KMS, whether it is for connectors for streaming data, for Kinesis and managed service for Kafka, whether it is your integration with your data warehousing solution with Redshift, or whether you want the data lake integration with lake formation, whether you want, SQL or no SQL kind of connectors as well. These are available. Now, when we deploy the EMR solution, there are few options. Okay, so the default option which everyone chooses is where EMR is getting deployed on EC2 instances, right? And this is something I'll probably try to show you towards the end of the session as well. But we do have other options as well, where we can launch EMR on EKS because of the the popularity of the Kubernetes. A lot of customers, they launch Kubernetes, and they are well versed with it. And now EMR can be launched on EKS clusters. And plus, for our edge services, we do have a solution called as AWS Outpost, and EMR is a service which is supported on, which is kind of supported on that Outpost rack as well. So even if you have that Outpost rack which is sitting in your data center and you still want to leverage EMR as a service, EMR can be launched on Outpost racks. And we do have EMR serverless as well, which we have launched, and this will give you complete flexibility, because EMR serverless is a completely fully managed option for you. You don't have to worry about like configuring the nodes and their configurations and how much CPU and how much memory and the softwares and their installation and configuration and scalability, security, everything AWS will take care, right? So these are different options which are there if you want to leverage EMR. All right. Now, because again, when you launch EMR, we talk about scalability. And again, there are a couple of options which you have. You do have the auto scaling option as well, but we have a managed scaling option as well, which is available in EMR. So EMR customers, they were enjoying the auto scaling, which was the default feature for a long time. And this is where you get to define the matrices based on which the EMR cluster can scale out or scale in, right? Depending upon the various demands which are coming in your from your compute perspective. But with EMR version 5.30, which is 5.30 and later, you can enable EMR managed scaling to automatically increase or decrease the number of instances or units in your cluster based on your workloads. So EMR, it basically continuously evaluates the cluster matrices to make scaling decisions that optimize your clusters for cost and speed both. And this feature is available for clusters which are composed of either single instance groups or instance fleets. So with this managed scaling, we manage all the configuration. You don't have to write any policies for scaling, like when it reaches this much percentage then add one more task node or something like that. You don't have to do anything of that sort. We will take care of this. All you have to do is tell us like what is your minimum and maximum numbers which you wanted to scale out and scale in, so that your costs are still under your control. All right. So if you compare, you know, auto scaling, it basically supports on instance groups, whereas the managed scaling works with both instance groups and instance fleet clusters on EMR. And with managed scaling, the matrices are collected like every 1 to 5 seconds, and they are evaluated like within like 10 seconds itself. Whereas if you go with auto scaling, it'll be like only after 5 minutes. So every 5 minutes, they will evaluate the condition which you have specified, and then they will scale. Now, if you look at this, like 1 to 5 seconds and then 5 minutes, you might realize that okay, it's not a big deal. But let me show you where it impacts. Now, it's a bit complicated graph. Don't try to pay too much attention to it. But there is just one thing which I want to show you here. This is a graph for cluster auto scaling. Okay, so this is where after every 5 minutes, you have defined the policies and it is scaling out or scaling in, right? Now, as you can see from left to right, while the pending container ratio increases, the auto scaling request more nodes to be provisioned, all right? And you can see this from the green line, all right? The green color line in the graph. So while around 9:45, if you look at the time graph, at 9:45, there is almost like no container spending when the cluster scaling is initiated. So they want to shrink the cluster, right? Now, since the classic auto scaling takes more of a step scaling approach, the time taken to bring the node count down, it takes a while, right? Because every 5 minutes they are evaluating. While another spike in the container pending ratio, it comes around 10:05. So if you look at 10:05, there is another scale up request to add more nodes, which quickly, dies down at around 10:10. And again, the node takes a while to be taken out completely. So during this period, the nodes are idle and they are not being utilized. All right. Now, if you compare it with the managed scaling, right? So we see a similar example now with managed scaling, and the EMR cluster is now quickly able to deploy and remove the nodes based on the container pending ratio. And the time taken to scale down the cluster is much faster, which results in cost saving from running the idle instances, right? And the scale up also happens much faster instead of like the step scaling approach. So, all in all, if you go with this managed scaling, then it's basically a feature which will automatically resize your EMR clusters for best resource utilization without the need to another, rules and policies to be written by someone. And with managed scaling, you just specify the minimum and maximum compute limits for your cluster, and the cluster will automatically manage the number of nodes or the count of these nodes to adjust these capacities. And again, managed scaling is useful in scenarios where the load on your cluster is like kind of unpredictable, because if it would have been predictable, probably auto scaling is better, because you will say that I know exactly at 9 o'clock two more instances needs to be deployed. But given the way, as I mentioned, the data is getting collected nowadays, it becomes really unpredictable, right? Sometimes you have less data, sometimes you have more data. And then when you have more data, the more processing has to happen. And when it becomes unpredictable by nature, then probably the managed scaling will save you a lot of cost. So cost reduction is the main USP for going ahead with the managed scaling, all right? And when we talk about, even we are talking about the cost, one thing which we need to understand is the cost saving for EMR is not just the support cost. All right, there is also savings made in the hardware acquisition. Think about the personnel cost, the maintenance cost, etc., etc. Right. So for IT professionals, their pain point with Hadoop is management costs. For the entire Hadoop cluster, including the node provisioning, the cluster setup, the configuration part, the version upgrades, the cluster tuning, the hardware setup in terms of the capacity planning and hardware procurement and data center cost. So these are also the cost which people don't appreciate fully, but again, this is something which has to be taken into consideration. And as I told you, we do have an option for spot instances. If you want to use, you can go with spot instances or spot fleet. There is a spot fleet advisor which you can use. You can definitely use the compute savings options and reserved instances which are supported by EMR. And as I told you earlier, you can have transient clusters as well, which you can terminate as soon as the job is done. So transient clusters are like short-lived clusters where you upload the jobs, and as soon as the job processing is done, the cluster is terminated, right? So it'll stop the entire cluster and deprovision everything, and will save you the cost, right? So as an enhancement, the instance fleet cluster configuration, this basically provides you an allocation strategy. And this is where you can choose like a mix of on-demand instances and spot instances. And even for spot instances, you can use like for capacity optimized allocation strategy and all. And this will help you to save a lot of cost. Let me show you this with an example. So imagine there is a big data processing which you have to do, right? And let's say this is something which is going to take like 10 instances, right? And let's say, just for simplicity, I'm saying that the 10 node cluster, it'll run for 14 hours and it can do my job, right? So that is an assumption I'm making right now. And just for simplicity of the calculation, I'm saying, let's say there is $1 per hour per instance, right? So you can see the cost, $1 multiplied by 10, which is basically 10 node cluster, multiplied by 14 hours, which is the total time it will take to run the job, right? So I get a cost of $140, right? Now imagine, instead of going ahead with 10 on demand nodes which I took in the first definition, what if I add 10 more nodes of spot instances? So I'm saying I still do have those 10 on demand instances. If they run alone, it'll take 14 hours and I will be charged $140. But now I'm saying, let me add 10 more spot instances. Okay, now, if I would have had this 20 node cluster, the first thing would be my time will be reduced, right? So instead of 14 hours, I will take only 7 hours, half the time. Now, I told you spot instances can give you up to like 90% of discounts compared to on demand, but I'm not even going aggressively like 90%. What if I'm getting like 50% discount, right? So now I'm saying that the on demand instances were $1 per hour. The spot instances, let's say it is 50 cents per hour, half the price. Okay. So I'm taking just 50% discounts, not even 90%. So now the cost of on demand, because I'm running 10 nodes of on demand just for 7 hours, is $70. And then add 10 nodes of spot instances, 50 cents each, that is $35, half of that price. The total price is $105. Now, what did you see here? Now I'm able to do the job with 50% less time and with 25% less cost. All right. And again, this on demand, which I have taken, if you want, you can go ahead with like even compute saving plans and you can further lower your bills, right? So that is how you need to think about like how should you configure it in such a way that I should be able to do my job in lesser time and probably with lesser cost as well, right? Both the things are important. Now, what about the performance? So EMR provides multiple performance optimization features, for multiple open source frameworks like Spark and all. And with Spark on EMR, you can get like over 2 times faster performance in the TPC DS3 TB benchmark compared to a standard Apache Spark. Again, Presto on EMR provides around 2.6 times faster performance over standard Presto. And with all these enhancements, you can utilize the faster performance for your 100% compliant workloads, compared to Spark or Presto alone, right? And again, you can see different benchmarking performance benchmark indexes and tests are available online, and that is something which is the reason why a lot of people they prefer EMR, because not only like it helps you to get away from unneeded undifferentiated heavy lifting and shifting, but also gives you a lot of performance as well, right? And it's 100% compliant with the open source frameworks which are available. But how about the security? I'm good with cost, I'm good with performance, good with ease of the architecture and scaling. But what about security? So there are a few things. See, number one, when you talk about the isolation, so again, isolation is provided via VPC. So VPCs can have both public and private subnets, and you can launch a cluster in a private subnet, and you can basically isolate it completely if you want. Similarly, for authentication, you can have the Kerberos mechanism, which is available for authorization. You can go with POSIX based authorization. You can have data encryption at rest, in transit as well. And again, for the audit, you have the ability to perform audit through logs which are there, and I'll show you these things like in the console. And if you think about the authentication flow, so imagine that users they use a single sign-on to authenticate, right? And this single sign-on can be integrated into your corporate Active Directory to verify the users directly. All right. And once these users are authenticated, they can access the EMR cluster using different methods, which might include like notebooks or step APIs or even the EC2 session manager. All right. So the strong integration from the authentication allows users to use the existing directory services and avoids the need to end users to directly connect to EMR cluster to execute the job. And throughout, no matter where your data is, you can basically go ahead and have the security configuration settings on the EMR cluster, where you specify the encryption has to be there both at rest as well as in transit. All right. And again, even if you are using like data lakes and S3, you know that S3 by default, any data which goes on S3 by default gets encrypted. So a couple of months ago, we have launched this feature in S3. Earlier, if you upload any data on S3, it could have been uploaded as a plain text data because the default encryption feature was none. You already had the option even then that if you want like the server side encryption to be enabled or KMS to be enabled, you could have done that. But now that no encryption is not possible, anything which you upload on S3 by default will get encrypted with server side encryption. All right. And again, SSL over TLS is used by a lot of companies for HTTPS for the data in transit. A lot of people they use VPN connections if they are transferring data from their corporate data centers to AWS. So these options can be used, right? Data throughout will be encrypted both in transit as well as at rest. Now, what about the EMR Studio? So, EMR Studio basically uses a managed Jupyter Notebook, which is basically a preferred option by a number of users, whoever uses the big data Hadoop frameworks. And if you think about it, there are certain challenges, like if you think about like I want to integrate it with your the notebooks with the corporate Active Directories. I don't want to do it like from AWS console, or I want even these notebooks to be fully managed. I don't want to take care of them. I want to simply connect to different repositories which are there. These managed notebooks should be able to directly connect to these repositories, or maybe I want to integrate the notebooks with Airflow, and step functions so that I can run some jobs as a step functions and all. or even you talk about ability to connect multiple notebooks to a single EMR cluster and all, or I want an ease in debugging in case there is some job which has some issues, some problems and all. So that is something where customers told us that these are some of the challenges which we are facing, right? So to answer all these questions which you see from different customers, right? So this is where we decided to launch EMR Studio. So EMR Studio is an IDE that reduces the time for your data scientists and data engineers to build and deploy the code. It is fully managed application with a single sign-on, Jupyter notebooks which are fully managed, and automated infrastructure provisioning, automated job diagnostics. All these features are there, and you can use your corporate identity to log directly into the notebooks instead of AWS console. You don't have to go via AWS console, and you can do everything, like you can develop, you can visualize, you can debug, you can optimize the analytics, and machine learning applications which you have. And you can collaborate with peers by sharing the notebooks via GitHub and other repositories. So imagine that you have a team of developers, right? And you want to analyze data from your data lakes using, I don't know, PySpark or SparkQL or SparkR or Scala, right? So Studio integrates, with Code Commit, GitHub, a Bitbucket, for easy collaboration. So you can import custom Python libraries like Pandas or NumPy and install custom kernels directly from the notebooks. And you can build pipelines, using the orchestration services like Apache Airflow. And that's why a lot of people they prefer to use EMR Studio. So in terms of the benefits, it's pretty simple to use. Your life will become easy because your interaction with your applications on an EMR cluster will happen seamlessly. You can access the studio from your corporate credentials using single sign-on, without logging into AWS console or without logging into an EMR cluster. You can interactively explore and process and visualize the data using these notebooks, and you can build and schedule your pipelines and debug applications without logging into EMR clusters. And these are fully managed Jupyter notebooks. So you can start developing your analytics and machine learning applications directly using R, Python, Scala, PySpark in seconds with these notebooks. And it's pretty easy for you to build your applications, and you can debug jobs and access the logs without logging into the cluster for both active and terminated clusters. So you can use native application interfaces like Spark UI, or you have Yarn timeline service, right? And all these features will help you to debug any failed jobs, without logging into the EMR clusters. And when we launched this EMR Studio, a lot of customers, they came to us and they said that we have petabyte scales of data analytics, right? And we need to do use EMR, but then we don't want to manage the EMR clusters altogether. So is there a way where we can achieve this in a serverless way? And that's where we launched EMR serverless. So it's a serverless deployment option for EMR, which enables the customers to run applications using open source analytics frameworks without having to tune or optimize or even, secure these clusters. So customers can simply specify the framework they want to use, and then they can run their applications using APIs, and then either via EMR Studio, or maybe if they have JDBC or DBC clients. And again, serverless will automatically determine and provisions the compute and memory, all the resources, the horsepower which is required for your jobs to run, for your applications to run. And it will automatically scale the whole cluster seamlessly, up and down based on the requirements of the jobs, right? So that is where EMR serverless comes into picture, right? And again, it will automatically secure your entire cluster and all the underlying resources to meet the compliance requirements. So customers can check the status of running the clusters, and they can check the status of running their jobs. They can see it in EMR Studio, they can see it in console, they can review the job history if they want. So all these benefits you get it from the EMR serverless. So think about the primary motivation why EMR serverless came into picture, why we built it on AWS is because with EMR on EC2, you can provision clusters of any size in minutes, right? And EMR automatically installs and configures the open source frameworks. It also gives you, full control over the configuration to optimize the performance and cost, right? So we wanted to make this experience even simpler. So serverless is basically an attempt to use, where you don't have to configure and optimize or operate or secure your clusters or those resources which you're running within the cluster, and all these applications which you are using, things like Apache Spark and Hive and Presto, the serverless should automatically provision them for you and dynamically scale them based on the need, based on the demand, right? And your jobs runs faster. It has its own performance optimization tunings, for different frameworks which are using. And again, it is 100% compliant with the open source, and you pay only for the compute time and the resources which you're using, right? And again, it has a lot of comprehensive tools to run your applications. It includes the EMR Studio, where you get your notebooks, and you have your Spark UI and Thales UI to help you develop and visualize or even debug your applications, right? So I thought I'll just take you to the console and probably show you some demonstration for the EMR. All right. So here, this is basically my console, and I can take you to EMR cluster. I'm basically in Oregon region, if I'm not wrong. Yep, I am in Oregon region, and this is the one of the cluster which I have deployed it. But how did I deploy it? I'll show you. So I go to the creating cluster. You can give it a name. I'm choosing EMR cluster. You can choose the EMR release. So let's say I'm choosing 6.3.0, and it shows me the application bundle. All right. Now it comes with this application bundle, so you can see it includes few things, as you can see here: Spark and Hadoop and Yarn and Zeppelin. Now maybe I want to customize this, so I can choose a custom option, right? And maybe I don't want big, but I want to add, let's say, I don't know, Spark. All right, so I can choose that. I can choose between any of these applications which I want, depending upon my use case. And then again, we come to the configuration of the cluster, and you can see here the instance groups. The first one is primary, and again, I get to see all the different options which are there. I'm gonna choose M4 large. I believe it gives me 8 GB. Yep. So for the leader node or primary node, I'm choosing the M4 large. So it has, you can see, two virtual cores, 8 GB of memory, and EBS storage. And if I want multiple primary nodes, all I have to do is check this option. So you will have 3 primary nodes. Right now, it's just for testing purpose, so I'm deploying just one. Again, for the core nodes, I'll choose the same configuration just for consistency. So I'll choose M4 large. And again, for the task nodes, I'll go with M4 large. Okay. So basically, I've chosen one primary node, one core node, and one task node. Okay, and each one of them are M4 large. All right. Now again, this is the place where I was talking about the scalability. So do you want to auto scale this, or do you want to use the EMR managed scaling? So you can give your maximum and minimum. You can choose whatever you want. From the networking perspective, I have created a lab VPC, so I'll choose that, and it should choose the subnet for me, which should be a private subnet. If I want to verify, I can see it as the private subnet, so I'm good. I can add my steps here if I want. And how do you want to terminate the cluster? I want to manually terminate the cluster, and I want to use termination protection because I don't want anyone else to accidentally terminate the EC2 instances. Any bootstrap actions if I want. The cluster logs, I can publish these logs to S3. So all I have to do is specify which S3 bucket. And this is your bootstrapping options. Then in the security configurations, I've already created one, so I'm going to choose that. And for the SSH into my cluster, I have created a key, and I have created a role as well just for the permissions, which is EMR default role. All right. And the instance profile is EC2 default role profile for EMR. All right. So again, I can, change the configurations, but this is, let's say, the configuration which I want to do. All I have to do is now click on create cluster. The moment you do that, it'll go into that creation of the cluster, and it'll take about, with my configuration, about 7 to 8 minutes, and then it'll deploy the entire cluster for me. All right. Now, what I have done is I've already pre-deployed the cluster so that I can show you this is the same configuration cluster which I was trying to choose. So you can see my EMR version is 6.3, and you can see it has capacity of one primary, one core, and one task node. And you can see here, these are the applications which I have installed. All right. And you can see here, I have the instances, and you can see the primary instance, the core node, and the task node. All of them are M4 large, right? So this is the same one which I have. And now what I can do is I basically want to connect to this cluster so that I want to probably get the cluster ID. I can see the cluster ID right now, so you can see here, this is my cluster ID right at the top. But let's say I want to get that cluster ID, and then I want to, from that cluster ID, I want to get to know the DNS, the public DNS of the EMR cluster as well, right? So what I can do is I can try to connect via my command host URL. So this is my command host URL. And I want to, as I said, I want to get the cluster ID, and I want to export it to an environment. And I want to get the public DNS name of the cluster, and again export it to the environment. And then I want to SSH to that EMR cluster, right? So all I have to do is I have to run those commands, and it should help me to SSH into my EMR cluster. So now you can see I have SSH'd into my EMR cluster, right? Now, what do I want to do? What I want to do is I want to export an S3 bucket name as bucket as an environmental variable, and I want to open the Spark shell because I have added Spark application in this cluster. So I want to open that Spark shell in the EMR leader node terminal. So let me try to run the command for that. Okay, so I've done that. So now what it'll do is it'll basically open up a Scala prompt for me, and that is something where I can create then a variable for the S3 path location. I can create a data frame, I can describe the schema of the loaded data, and I can view the table content. And what I want to do is, let's say I have some stock ticker prices. Okay, so these different companies who have different stock prices on a given day. So let's say I want to know what is the closing price of the ticker symbols for some of these companies, and I want to, let's say, organize it in a descending order, right? Or maybe alphabetically, I want to start sort it out, right? So that information is there in my bucket. So this is my Scala prompt, and what I'll do is I'll basically run my command for that. And just keep an eye. What I'm doing is I'm first of all you know creating a variable for the S3 location path, which will then create a data frame, and then I'll describe the schema of the loaded data, and then view the table content. Okay, and now it'll show me the stock ticker prices for different companies. So here you can see this, you can see the ticker symbols for Apple, Amazon, GE, and so on and so forth. And you can see the max price at which they were closed, right? And this is what I wanted to analyze probably, right? So what I can do is, if I'm happy with the result, I can exit this, right? And this is something which was a part of a batch analytical job, right? Now, Another thing is I talked about or touched upon, at least from the security perspective, right? So let me do one thing. Let me clear this, and let me connect to my EMR leader node again and do the SSH. I think I should still be connected, but still just for the sake of simplicity. Okay. Now what I want to do is I want to kind of export the S3 bucket name as a bucket environmental variable. So what I'll do is I'll just execute the command for that. So you can see this lab stack is the name of my bucket. Now, next, what I want to do is I want to write an encrypted object to S3 from my EMR cluster. Okay. And the name of the file should be output file. And the text which I want to pass it on is like this is a practice lab or something. Okay. So let me do that. So this is the, I want to create this file, and I want this text to be written in that file which is created. All right. Now what I want to do is I want to write this file, to S3 bucket using EMRFS file system. So I'll just go ahead and run the uh, output file command. Yep, done. And now what I have done is I have written a file as a client-side encrypted object at rest using EMRFS to S3 bucket, which I've created as part of the lab, right? Now that we have encrypted the object, we need to see like what the encryption did to the object in S3. And what I want to do is I want to decrypt that, all right, because it is encrypted right now. So the first thing I'll do is I'll try to download that encrypted object directly from S3 bucket into another file, which is encrypted output file text. So let me just paste that command. I've downloaded it. Now I want to cat. So I just want to see like what is there in the text internally. And you can see this is like completely encrypted, right? And what I want to do now is I want to run a command so that I can decrypt and read the object from S3 into EMR cluster using EMRFS, right? Because I know that it is encrypted right now. So all I have to do is run the command for decryption, and it is doing its MapReduce. Done. So you can see now it says this is a practical lab. So this was the actual text which I had inserted. So that's what I had planned for the session. And what I want to do was I wanted to ensure that you folks understand the the different options which are there in S3, and the S3 option in the EMR cluster, and how you can deploy one and how you can take it into consideration, right? So that's what I wanted to do. And there are many customers who are using EMR, and they have used the EMR as part of their solutions for the different challenges which they were facing. For example, this is the FINRA. They had the legacy system which wasn't scaling well, and they wanted to integrate the Spark on EMR with Hive Metastores. Similarly, Cisco is the leader in selling and marketing and distributing the food. And again, they had large volumes of data in multiple systems, which was costing them quite a lot. So they created a solution with EMR along with S3 and Athena. And same is the story with NASDAQ as well, where they wanted to make their large historical data footprint available to analyze as a single data set. So they had to use data lakes, data warehousing solutions with Redshift and Presto on EMR. And this is their architecture, which they achieved it how. So that's probably my time, and that's where I'll stop. Christina, over to you.
Thank you so much, sir, for your informative session. I guess that all our audience in the live session has enjoyed it very much. So, moving on to next, we'll be having the live quiz section. For that, I would be inviting Jaya. So, Jaya, if possible, please go on with the live quiz session. Over to you.
Good evening, everyone. So, guys, scan this QR and join the Slido. We will be starting in a minute. So, let's start the quiz. Which AWS service did you use before? Oh, no, Okay, moving forward. welcome back. Yes, ma'am. The quiz is done. Christina, over to you.
Thank you, Jaya. Thank you, our lovely audience, for attending the quiz. So, as I can see, maybe the winner of the quiz is Swadhin, if I spelled it correct. So, our team will contact you, and maybe you get some digital badges from our end. So, definitely. Congratulations and thank you, Mr. Saurabh, sir, and the entire team of AWS Cloud Club at Lovely Professional University for making this event such a grand success. I would also like to thank all our audience for joining us live today. Hope you all enjoyed and have a wonderful experience. The link to the feedback form is pinned in the description. So kindly fill that form to avail your participation certificate, and our team shall mail you the certificates. For any further details, kindly mail us at awscloudcommunity.lpu@gmail.com. So that was all about today's session. Signing off, I, Christina Borwa, thank you for your immense participation. Thank you and goodbye.